Hello, virtual statistics and pre-calculus. Welcome to day 1, April 1st, April Fool's Day, 2020. The topic today is the parent function, a new parent function, the reciprocal parent function, y equals 1 over x. If you don't have your big blue book handy, even though it said to do that on the top of my HB, get your big blue book handy. Make it all there. If not, you can do a new page, or you can, take your notes someplace else. This will all be good. But we are looking at the parent function of y equals 1 over x. A little bit of what the graph looks like. It's kind of interesting. We can actually go there and drag a point around, and it will be interesting. If you have x equals 1, 1 over 1 is 1. 1 over 2 is a half. 1 over 3 is a third. No surprise here. 1 over 4, believe it or not, is 1 quarter, 0.25. 1 over negative 2 is kind of interesting. 1 over negative 2 is negative a half. 1 over negative a half is negative 2. How about that? And 1 over, say, negative a third is negative 3. Very interesting stuff. The graph looks a little different than most of the graphs we've seen so far, but let's talk domain and range. You can see from the graph that there's some peculiar stuff going on. You can see, for instance, that it's not defined when x is 0, which makes sense because you can't divide by 0. You know that. So the domain is that x can't be 0. Also known, x could go from negative infinity up to 0, but not include 0, and then pick up again after 0 and go on to infinity. The range, likewise, is y is not 0. Again, y can go from negative infinity to 0, and from 0 up to infinity. And you could see that on the graph because there's no place where y is 0. It keeps getting closer and closer. It doesn't actually touch the x-axis or the y-axis. There are no intercepts, but there are two asymptotes. The x-axis, also known as y equals 0, and the y-axis, also known as x equals 0. Key points on the graph that you can see labeled here: 1, 1, negative 1, negative 1. They are there, and the graph has interesting symmetry, does it not? It is symmetric over the origin, like any other of our functions. So for instance, the point 4 and 1 quarter is on the graph, so is the point negative 4 and negative 1 quarter. So we're talking about over the origin, which makes it an odd function. But it's also got two more lines of symmetry that are kind of fun. It has a line of symmetry over the line y equals x. It also has a line of symmetry over y equals negative x. Symmetric both of those places. If you want to pause now to write all of this down, you can pause now, write all of it down. We're all good, and I will go on to the next slide when you are ready. Continuity. You cannot draw this graph without lifting up your pencil. It is in two separate, distinct parts. It actually has, it's called an infinite discontinuity. At x equals 0. When x equals 0, it is infinitely discontinuous. You can actually draw your asymptote on it at x equals 0, and it doesn't touch, and it goes off to infinity in both directions. End behavior. As x is going to infinity, y is going to 0. But it's always positive. So the bigger x gets to 100, and y is 1 over 100. X gets to 1,000, y is 1 over 1,000, but it's always still positive. Likewise, as x goes to negative infinity, y goes to 0, but it's going to be negative. If x is negative 10, y is negative a tenth. If x is negative 100, y is negative 100. Negative 1 over 100. If x is negative 1,000, y is negative 1 over 1,000, really small. The max-min points, there aren't any. Think about whether you think this graph is increasing or decreasing, because it's a peculiar answer. There's actually no place where if you walk left to right, it's going up. It is always going down. It's always decreasing left to right. It does have a discontinuity at 0, like you know. So it is decreasing from neg infinity to 0 and from 0 to infinity. And it's discontinuous in the middle. It's discontinuous at 0, so that breaks it up. An alternative form, it's kind of helpful. We'll get to this on the next one. But if you write this, if you multiply both sides by x, you get x times y equals 1, which is kind of interesting. And that's why you get some of these good points. You get x equals 5, y equals 1/5. X equals 10, y equals 1/10. And you multiply them and you get 1, and you have all sorts of good things. And it has some applications too. The main application this has is if you have constant time for working on things. For instance, if you have a job that takes 20 hours and you have so many people available, if you have one person, it would take 20 hours. If you have 2 people, it would take 10 hours. If you have 5 people, it would take 4 hours. Things like that. And that's also more helpful on the x times y is 1 version, or the x times y is, in this case, we would have been 20. X times y is 20 to see how we've got. So here's your summary of your parent function, y equals 1 over x. Hope you understand all the different pieces of it, and take a look, and we will check in again tomorrow with more. Be sure to check in on some of the community events, and to fill out the exit slip to make sure that you know exactly where you are and how things are going. Thanks very much. All right, stop.